6.1 cubic parent functions. We're going to be working on our new function, the cube. You can call it the cube function or the cubic function. How you would read this particular problem right here is x cubed. So that is x cubed, or x to the third power. We're going to put it in our calculator. We're going to actually graph it so we can see the picture. And then we're going to go ahead and work on transformations of it. Now, we've done transformations before, so that won't be new to you. But we are going to graph this. So you're going to go y equals. You've got x, but you need to raise it too, so you're going to go below clear here, that little caret, or people call an up arrow, not this up arrow, but below clear. Raise 2, and you'll get a little exponent. You put your 3. We're going to look at the picture of it. It does not have a specific name, so that's just the graph of the cube. And if you notice, it looks like it hits 0, 0, but we're going to go to the table and check. Does it hit 0, 0? And we see that it does, so we're going to plot that point, 0, 0. And we're going to go above 0, 0, and we see it hits -1, -1. And we're going to go below, and we see that it hits 1, 1. And if we're not careful, that looks like we're making a line, but we are not. When you look at the graph, it's not linear. So we need to go back to the table, and we're going to go below 1, 1, 2, 8. We're going to go ahead and make sure we include 2, 3, 4, 5, 6. We ran out of space, so 7, 8. And I'm going to go ahead and label this as 2, 8. Okay? I'm going to go back up to -1, -1 that I've already plotted, and right above it is -2, -8. Again, I'm going to have to come off the graph, and I'm going to go ahead and label it. We'll write domain over here. It'll be fine. Now, I need to graph that picture. I've got enough points, and now I can tell. So I always start at 0, 0 and curve up, except I missed my point. Sorry. And then I'm going to start at 0, 0, and I'm going to curve down. That one was much better. And I've got my picture like what I see here. This looks like half of a parabola, and then they took it and reflected it over. So it's just a parabola that kind of broke in half. But again, it doesn't have a name. But we do need to come up with the domain. Remember, all domain moves from left to right on a graph. And some students want to tell me that this graph starts at -1, but at -2 I have a point. At -3 I'll eventually hit this graph because it's coming down, but it's also coming to the left. At -4 I would eventually find the function. At -5 I could do that forever. So I'm coming, oops, I don't know why I did that. That was weird. I'm coming from -infinity. From the left, -infinity, and as I move, I hit 0, I hit 1, at 2, at 3, eventually I will find the function, at 4, when x is 5, when x is 6, so we're going to go to positive infinity. Now the range is a little bit easier to see on this one because we're coming from the bottom to the top, and I have an arrow that tells me I'm coming down forever, which means I don't have a starting point, so I'm coming from -infinity. I have an arrow headed up to the top, which means I'm headed to infinity. Now, -infinity to positive infinity can be all real numbers, is what people will say. And the symbol for that looks like 2 vertical lines, and then you connect to make an R. Okay, so you can see any of that on a test when I ask you for the domain and range of any of these functions, but it is all real numbers. Now we're going to leave our parent function in, and we're going to start with D down here. We're going to write what it does. I will remind you really quickly, that's our parent function. So we're going to do x raised to the third power. You'll have to right arrow over and put +5 or whatever. You don't have to put anything, you can just watch. My new function, clearly, from 0, 0 went up 5. Okay, if I change that +5 to a -5, hopefully you remember that you're going to see your parent function there, and your new function will move down 5. So what we want to write about D right here, this letter at the end, is our vertical shift. Again, we did this 4 times last semester, so this isn't new information. Positive goes up, negative moves down for D. Alright, then we're going to work on C. So we're going to talk about this letter right here. Now, when you do a C being entered, let's go plus first, 5, you have to put the C, notice it's in parentheses. So notice my C is in parentheses, plus 5, there's my parent function, there's my new function. Notice it moved to the left 5. If I were to change this to a minus, we should be seeing the opposite direction. So we should be seeing going to the, if it'll hurry up, right 5. Okay, so we're going to write that this is our horizontal shift. Okay, if you have a positive, you're going to go to the left. If you have a negative, you're going to go to the right. That's what our C does. Now we're going to skip up to the top, and we're going to do A. Just because B is brand new to us, and we haven't done a ton with it, so we'll do it last. Hopefully you remember that you're negative A, and I'll show you in a second. It's going to reflect over the x-axis. So you can write that while I type it in. I'm going to do negative x raised to the 3rd power. Just to be sure that I am clear, I'm going to go ahead and put parentheses. Notice that the negative is in front of the x cubed, so it is A. So we're going to go ahead and hit graph. That's my parent. And there's my reflection. Over the x-axis, blue came down. Over the x-axis, blue came up. Alright, so that's my reflection. Now, A is also our vertical stretch or compression. And we need to remember that we are going to stretch when we're greater than 1, and we're going to compress when we are less than 1. Again, I can type an example in while you are writing that. I'm going to do 2 parentheses x to the 3rd power. Alright, so A is out front. Notice it's in front of the parenthesis. 2 is greater than 1, so I should see a stretch happening. And there's my parent function. And a stretch means I'm going to take the y-axis and I'm going to pull it. And as I pull, that blue function comes in. That 2 is a little hard to see, so let's go with a 5. Okay, so there's my parent. And there's my, again, I'm going to pull, so you can see that the blue function moves in as I pull the y-axis up and down. Okay, so if you want a compression, I need to be less than 1, so no, don't hit that. We're going to hit this, and we're going to do, let's just do 1/4. So it is easy to see. And when I graph, that means that I'm going to take the y-axis and I'm going to compress it. I'm going to push it together. And as I push, the blue should fall out. And that's exactly what we see happen. As I push together, blue is falling out to the red. So that's my compression. Alright, now we're going to do B. And B is the one that is really, really, really pain in the rear end. Negative B is still a reflect, just like negative A, except we're going over the opposite, so we're going over the y-axis. I will show you what that looks like. Oops, I didn't mean to do that. Just kidding. Go back. X raised to the 3rd power. Clear this out. Now, this time I need the negative inside the parenthesis with the X. Notice B is going to be inside the parenthesis. So if you watch this graph, this is a reflect over the y-axis. There's your mother function. This part is going to reflect over. There you go. This part reflects over. They look identical to this reflection. You would never be able to tell on a graph which one. You can only tell if I'm reflecting over x or y based on your equation, whereas the negative at, you can't tell from a graph. It looks identical. In fact, yeah, no, I won't show you. Okay, so B is the opposite. Reflect X, reflect Y. Instead of horizontal, vertical, we're going to do horizontal, stretch and compression. Okay, and then you need to remember, again, B is going to be the opposite. So instead of greater than 1, stretching is going to be less than 1. Instead of less than 1, we're going to be greater than 1. And don't forget, this one is a reciprocal. So what that means is if B was 3/4, I would actually say 4/3 is my answer. That's the reciprocal. So those are our transformations. A, C, and D we've done for a long time. B is new, but it's the opposite of A. We've done that a little bit. You do need to take the reciprocal when you're working with B. Alright, we are going to flip our notes over to the back side. This is a cubic or cube function. Either way, you can say cube or cubic. But when I read this, this is y equals x cubed. Okay? Oh, I guess before I turn it over to the back, let me do a little bit of something you don't need to write down. We had x squared, which was a quadratic function. And mathematically, if I wanted to do the inverse of x squared, I don't know why that came so far apart, then I would say the square root of x. They were inverses, squares and square roots. Okay. Right now we're working with x cubed. So what would the inverse of x cubed be? Well, I'm not sure. I had an exponent, I went to a root. You have an exponent, you're going to go to a root, except I can't do a square root to 2. I'll have to do a cube root. What in the world? Yes, this is a cube root. So in a square root, we would come out of a square root in pairs. 2 times 2, so we know the square root of 4 is 2. That's a pair, a group of 2. When we're doing a cube root, we're going to come out in a group of 3s. So notice that that is 4 times 2, which is 2 times 2. See, I have a group of 3s. Now, can I prove that mathematically in a calculator? I can. See my cube root on the screen? I'm going to put 8 in there. What that is telling me is that 2 times 2, which we know is 4, times another 2 is 8. So the cube root of 8 is 2. So what you need to understand, inverses. The opposite of squaring, or that exponent of 2, is a square root. The opposite of cubing, or the third power, is to take a cube root. We're about to look at that on the back side. Okay, these are inverses. Exponents to root. Exponent to root. If it's a cube, we cube root. If it's a square, we're square rooting. Notice the square root doesn't have a 2. On my calculator, there's my square root button. There is no 2. Okay, we don't write it. It's understood to be a square root. If you notice on the back side, there it is. There's the inverse, the cube root. See, there's a 3 in there. Now, if you notice, I've had A, B, C, and D again. But these transformations never change. The function changes. The transformations don't change. So I'm just going to write same as the front. Or look at the front. Or exact same. Whatever you want to write. But there's no reason to write all of this again. We know about transformations. They're the same here as they are on the front. It's just that I have a new function. I have a cube root. That's what we say. That's how this is read. This is a cube root. Some people try to tell me that's a cube square root. It's not. This says the cube root of x. How do I find that in my calculator? Write that on your paper. Math 4. I'll show you, but you want to write that down. So we want to type this guy into y equals. So I'm going to hit math like it told me to. Math. And look at number 4. See how that's a cube root? So we hit enter. There it is. Cube root. But I got to put an x in there. So now I have this function, and I'm going to go ahead and graph it. Now if you notice, this graph is a horizontal graph. Looks like a squiggle horizontally. I said that cubes and cube roots are inverses. Look at my cube graph. It's a vertical squiggle. The inverse of vertical is horizontal. These two functions are inverses. So we're going to get points. It looks like it hits 0, 0, so we're going to go there. And sure enough, there we are. It hits 0, 0. So we're going to plot 0, 0. Right above it, negative 1, negative 1. Right below it, 1, 1. This one looks linear too, based on those 3 points. But those 3 points don't tell me the whole story because that's my picture. So you need to go back and go below 1, 1. That's all decimals until I get to 8, 2. 2, 4, 6, 8, 2. It's off the graph, but I'm going to go ahead and put it and label it. Okay? But I need a point, that's up and to the right, but I need something back here at the left. So I'm going to go up. There's negative 1 that I have. I'm going to keep going. Decimal, 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 decimal. Look at that. Negative 8. That's negative 6, negative 7, negative 8, negative 2. And I'm going to write it right here. Alright, I want those points. And to help myself graph it, I'm going to look at the picture. So I start at 0, 0, and I go up and to the right. You can also turn your paper. Sometimes that helps me. And at 0, 0, I'm going to come back and to the left. Now the domain is super easy to see here. I'm coming from negative infinity because there's no starting point and there's no stopping point. So negative infinity, I can't write that today for some reason, to positive infinity. The range from the bottom, some students think it stops right here. It doesn't. It keeps coming down slowly. You can see it here. It's coming down slowly, and it's never going to stop doing that. So I'm coming from negative infinity, and I'm headed up slowly to positive infinity. Again, I'm at all real numbers for a domain and range. Okay, my transformations are going to be exactly the same. Vertical shift, horizontal shift. Negative A reflects over X, negative B reflects over Y. Vertical stretch and compression, horizontal stretch and compression. They will be the same. So what I'm going to do right now is I'm going to do this last graph, and I'm going to use 3 different colors. So I would suggest for yourself that you do, I'm going back to Y equals, okay, notice that it asked me to graph the cubic parent function in one color. I'm just going to pick a color that we can see really well. I'm going to say it's going to be in blue. The parent cubic, that's not a cubic. Parent cubic function is x cubed. Sorry. So I have it typed right into my calculator. You're actually going to copy this graph, but for all intents and purposes, we're back here. You can't see it. So I'm supposed to graph the cubic, which is the one I just saw. We got it typed in. We're going to go to the table. And we're going to look for good points. There we go. So we got negative 2, negative 8, and I'm going to label it because I need to have that because it's off the graph. I've got, come on, negative 1, negative 1. You notice 0, 0 is there, and so is 1, 1. Hopefully you remember this from just a minute ago. And we've got 2, 8. And I'm going to hit graph so I remember which shape this is, and I do it correctly. So this is half the parabola, and the other half fell down. Okay? So in one color, we're graphing the parent cube that we had just done not that long ago. On the second option, it asked me to graph the cube parent. So we're going a new color. And that one, the cube root, is right here. So you can look up at your paper. Can't show both at the same time, but it still had 0, 0, 1, 1, negative 1, negative 1. Those 3 points are there. 0, 0, 1, 1, negative 1, negative 1. we had the outlier of 2, 8, 8, 2, and negative 8, 2. So we're going to put those on the graph. 4, 5, 6, 7, 8, 2. And we're going negative 8, negative 2. And remember, this is the S shape, or the snake, or horizontal, whatever you want to call that. So I'm going to go up to the side, and I'm going to come down to the back. So I should have that kind of weird crisscross going on. Okay, so that was number 2. Now I'm going to pick a third color. So I'm going to go with green. And I'm supposed to plot y equals x. Well, if y is 5, then x has to be 5. 5 equals 5. 4 equals 4. 3 equals 3. So I'm going to graph 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. I'm going to graph negative 1, 1, negative 2, 2, negative 2, negative 3, negative 3. Okay, whatever y is, x is 2. So they're the same numbers. Notice that that is my linear parent function. If I fold my paper, I'm going to do my best to fold my paper along that line. When I do that, this pink part is going to come up and become the purple, or the purple is going to come down and be the pink. Notice that the inverse of 2, 8 is 8, 2. We've studied inverses, x and y switch places. Notice here, I've got inverses. This point comes up, becomes that point. So question number 4 says, what is the relationship? The relationship is they are inverses. Inverses. And means a whole bunch of points are coming next. How do you know? They reflect over y equals x. Not the x-axis, not the y-axis. They reflect specifically over y equals x. They become the same thing. They will lay over each other. Let's see if y'all can see it. If I turn it, you can see the blue. It's hard to tell. Blue becoming the pink, maybe. Okay? So, that is inverses a little bit about these two functions. They are inverses, so you need to know mathematically x cubed is the inverse of the cube root of x. Those are mathematically inverses. The points are inverses. The graph's an inverse as it reflects over y equals x.